I'm going to show how to use an interactive simulation that demonstrates how to use a ternary phase diagram. This is a basic ternary phase diagram without any phase separation. Let's just look at what this simulation looks like. So the idea is that a point on the diagram represents a unique composition, and the mass fractions are shown here on the left, and then it's shown on the diagram how we read them. So for component A, 0.33 means that we've read along the horizontal line. If we had been up here, somewhere along this line, it would have been 0.90. Along this line, with 0.90 of A. This is pure A, pure B, pure C. And it's set up that we've labeled this side of the diagram for A, this for B, and then this one for C, where we read off the values. So, for example, 0.6 represents, for component B, somewhere along this line is a mole fraction of 0.6. So we'll look at the interactive simulation to better understand how to use it. So here's the ternary phase diagram. You can see I can move this point to different compositions and it reads off the values. We also can look at an alternate way of reading the values, where 0.026 for component B means we're 26% of the way between this face of the triangle and pure B at the corner here. So you can see as we move the point, we increase this value here. We're 90% of the way. So mass fraction of B is 0.9. This simulation also has the option of hiding the mass fractions and then picking a random composition and asking you to determine its value to make sure you understand how to read this phase diagram, and then showing the composition to check that you indeed have the correct mass fractions.